Hello everyone. This session we would be dedicating our discussion to something what is known as image tutorial. A very different kind of stuff which is possible with the help of the Matplotlib library. What if you could import your image data into the form of a NumPy array? Well, this might seem impossible to you, but that's very possible and easy with the help of the Matplotlib library. So with the help of the Matplotlib, you can simply import an image data into the form of a NumPy array and vice versa as well. That means if you have some image in the form of a NumPy array, you can simply plot it into the form of an image. Now we need to understand certain facts before we move ahead. One, this is the image we would be considering the ant image that would be considering for our example. Now let's say there's a 24-bit RGB PNG image. Now we'll be talking about PNGs only because and I particularly advise you that don't go for JPEGs. If you wish to go for JPEGs, then it's better you convert it into PNG. You can deal with JPEGs also directly, but then certain extra commands are there which I have not mentioned here. So 24-bit RGB PNG image. 24-bit means 8 bits for R, 8 bits for G, and 8 bits for B. Okay, that's how it becomes 24 bits. Now, the data type here would be float. Okay, how I will tell you. So when you will import this image into the form of NumPy array, you will find the array values in the form of floating numbers. Floating number means with decimal points. What Matplot does is it rescales the 8-bit data from each channel to the floating point data between zero point 0 to 1. So you have a PNG image which is 24-bit, 8-bit for R, G, and B respectively. It will rescale this 8-bit data into a floating point data which ranges between zero point 0 to 1. This is what happens when you use Matplotlib and import image data in the form of a NumPy. I will show you how it happens. Now, there are few aspects that you need to understand here. One, that most of the displays render only 8 bits per channel. Per channel means for R, G, and B. Now, this is because that's what a human eye can see. You have to go into little bit principles of photometric and photography for that all that stuff, but this is what you can understand. Now, each inner list represents a pixel. So when when the data image data gets converted into NumPy, each inner list will represent a pixel. And if it's a black and white image, then RGB are all similar because there are no colors. So black and white means there are no colors. No colors means that RGB everything is similar. Okay. There is a possibility that there might be an RGBA image where A stands for alpha or the transparency levels. Okay. For RGB and RGB images, Matplotlib supports float 32 means floating numbers as well as U in the UINT 8 data type. Both data types are uh, equally supportable. If an image is grayscale, then the Matplotlib supports only floating points, means float 32. It's very easy to plot NumPy array as images. Means if you have an image in the form of an array, and then you want to plot it as an image, it's very easy using this particular function. Okay. Now this is the code we have. Now it will be more clear how this thing works. So these are the necessary modules that you need to import. So from the matplotlib.pyplot, you would be importing the PLT. Matplotlib.image, you will be importing mpimg function. Then this is to import the file. So you have to give the directory address where it is. So you need to use the code mpimg.imread, all right, and then you have to give the address of your file. So I have and.png stored in my documents folder, and then print img. All right. So let's do this stuff one by one because that's way to be more clear. Okay. So let me take uh this one only. Let me okay. So let us take this entire code. So importing the matplotlib. Okay, and then importing the matplotlib.image. Then this is where I am importing my file from my documents folder and run. So now you can see this image has been converted in the form of numpy array, and these are all floating numbers. That's where where I discussed here that the d type here is float. Why float? Because you can see the decimal points are there and all the values are between 0 and 1. This is another thing we discussed, that what matplotlib do is it rescale the 8-bit data into the floating point data ranging between zero point 0 to 1. So see, the entire data is ranging from zero point 0 to 1. All right, this is how it works. So you have converted an image into a numpy array. Okay, that's how you basically you do it. Clear? It's simple, very simple. There is, it seems difficult, but that's not the case. We have done more difficult things than this so far. Then you can reverse it also. That means you can, if you wish, you can plot an array into an image. Means if there is some image which you have already stored in the form of a numpy array, or you have written some array for an image, then you can use this function plt.imshow. Okay, so if you run this, see, this is the image we got. So now what it has done, it has converted this numpy array, okay, in the form of an image. So this was where I imported my image, converted into numpy array, and then using this code I can simply uh, sorry so using this code I can simply convert my numpy array into image, the reverse, basically the vice versa case. So this is the image, this is the image I have. Okay, now there are certain customizations we can do. We can apply a pseudo color schemes to our image plots. Okay, so this is something very excellent customization you can do. Now pseudo color images can schemes or pseudo color means that you can enhance the contrast of your image, or you can visualize your data more easily. Sometimes what happens, especially in grayscale images, this is very common, or in black and white images, this is very common. It is very difficult to visualize your data because the entire image typically seems to be same. So to visualize it from different aspects, different angles, pseudo colors can help you. Okay. The logic of pseudo color is more relevant to grayscale images, obviously, because if an image is already consisting of a lot of different colors at different points, then the visualization is not at all difficult. All right. Now to introduce pseudo color, you have to first do the array slicing. Okay. Slicing means cutting down an array. So this is what we use. So I'm creating a variable im underscore img equal to img. So this represents rows, this represents columns. So I use a colon. So that means I want to select all the rows and all the columns till the end. Okay. So you can learn more about array slicing, or I'm assuming that you know a lot of things about array slicing as a basic part of the Python. Then you can add color maps. Default color map is this. Okay. So if you will not mention any particular color map, that is what it will take. So plt.im show, I want to show this image what I have created. Okay, and if you want to customize your color map, then you have to provide an extra argument, which is cmap argument. So suppose I want to customize my color map as hot, so I will say cmap equal to hot. There are number of color maps, so this is the link where you can go and you can check different color maps available, and accordingly you can use it. Okay, so let us stick it into the code. Let us see how the uh, logic of this works. So okay, so let me remove the color map option for the time being. Okay, so understand it better. So suppose, let's say we do it like this way. You can see this is the by default color map with this that has been added. Okay, so if you'll not mention any particular map, now you see, you get more clarity about the image, what the image is all about. So that's where we said that the concept of color mapping is more typical to grayscale images or luminosity images. Okay. If I add this extra argument where I myself will mention what type of color map I want, so you can say this is the hot color map. So you can try different color maps, and accordingly you can see that which color map is giving you a better visualization. Right. So about what all color maps are available, you can on this particular link. You can predefine your color map options also with the help of set underscore cmap. So if you will, before the starting of the code, if you will define this option, then automatically whatever image you will produce will take this code, will take this color map option. So either you can use set underscore cmap, you can define the color maps in advance, and then all your existing plots will automatically be converted accordingly. You can add a color scale reference also. Okay. So what a color scale reference is actually, let me tell you, showcase you by applying the example. So in the same image, suppose I want to add a uh, color scale reference. So this is my color scale reference. This is something what you have seen in contour plots as well. Now this helps you know that where the majority values lie. Like for example, where the color is much green, the majority values lie are lying here. So we want to, different colors. If you see this color is like yellowish, so this somewhere here. So that's the way, you can better visualize your image in the form of numerical values. Okay, that is the color scale reference, just like you have done in contour plots as well. Then another type of customization that you can do is using an interpolation. Now, what happens? Sometimes the images are not available in actual. That means they are resized. Now, what happens when you resize an image? It creates a lot of problem because when you resize the image, the gaps are created. Like suppose you are decreasing the size of an image. Now, what happens when you are decreasing the size of an image? Then a lot of spaces are created in the data. You have to understand it in the way that every image is just like a numpy array. If you change the size of the of the image, the numpy array also changes, and it automatically creates spaces in the data. Now by default, if you will not mention anything, the function will automatically try to fill those spaces, and it might produce a lot of over pixelation. Okay, your entire photo might be blown up, it might not be clear, it might be all hazy. So to avoid that thing, we can introduce this array interpolation scheme. So we need a pillow library, so pil we import the image function. Okay, so we import the request image. This is the function to import the image. Okay, so for interpolation, from pl we import image, then we import the image from my documents folder. Okay. Now I have resized the image intentionally because I want to show you how the array interpolation schemes works. So I have given it a size of 64 by 64. So when the resizing will happen, then automatically the gaps would be created within the data, and there would be some that filling needs to be done so that the image is not over pixelated or is not blown up. So you show the image. Okay. So let's do it here till here. Let us show the image after resizing. Okay, this is my original image without resizing. This is not resized, and this is my resized image. Sorry. Now you see. Now I have changed my image. This was my original image. It was clear. Okay, this image is absolutely clear, which is original, and this is my changed image. Now if you see, I have resized my image, maybe increase, maybe decrease, and see what it has done. The entire image has become somewhat unclear, hazy, pixelated, over pixelated. So now it becomes difficult to visualize. If you apply any color map scheme to it, any type of customization to it, you might not be able to visualize this image, because ultimately, because of the spaces in the data, the entire thing is blown up. Okay. So what you can do, you can use an interpolation parameter. All right. Like for example, we have using a bicubic interpolation parameter. What happen when you use this bicubic? the image will become blurry. Okay, so it, like for example, let me use it and then show you how the things will differ. So what I will do, I will okay, so now I'm using an interpolation which is bicubic. Okay, and if I run it now, the image is still not clear, but it is not blown, it is blurry. Okay, now if you image compare this blurry image with the earlier image, this image seems to be better. So what happens that when you use bicubic interpolation, okay, and your photo is blown up, you get a blurry image. Okay, so it's better than pixelated. You know, pixelated image is all blown up, it's very difficult, it's you are not able to see what is there in the image. But if you have blurry image instead of pixelated, then at least you can see what's in the image. Okay, so that is why if you find that because of resizing your image is blown up, it has become pixelated, then it's better to go for a blurry one, and then you have to give this interpolation. There is another type of interpolation which is available nearest, but I have never seen it working much. Okay, now the nearest what happens when you use nearest interpolation, it tries to fill spaces on the basis of near values in the data, the values which are near to the space that has been created. But I feel bicubic is better as compared to nearest. Otherwise you can try and you can see under what section you are getting a better visualization, accordingly you can place your data. Okay, so this is how uh, you can import an image into the form of numpy, and vice versa. That means from a numpy array you can form an image, and then you can do a lot of pseudo color schemes customizations, color map customizations, or interpolation schemes that you can introduce for the better visualization of your images, right? This is how you analyze an image data. So far we have been discussing about numerical data, categorical data, log data, and different types of data we will be discussing in the future. But this is something exclusive, very exclusive, that what we are discussing is about the image data, how to deal with the image data. Okay, the last thing which I want to tell you is how to import a 3D axis into the plot. Now, so far, whatever plots you have done were all into 2D axis, but it's possible that you can introduce a 3D axis as well. Uh, the use of 3D you might not find much unless and until you are dealing with that type of data which has that type of representation. So normally when you have three variables at least, then this data is, I suggest to use 3D data when it is three or more than three variables. Otherwise 3D data will not make much sense. Otherwise you are free to do if you want. Okay, so how to uh, inculcate a 3D axis? Very simple. This is the import scheme that you need to go for. So you need to go for the mpl underscore toolkits dot m plot 3D library module. You need to import axis 3D. Okay, then figure plt dot figure, and this is the extra function that I am defining here. Ax is equal to fig dot add underscore subplot, and I need a 3D projection. This is a standard code that you need to run if you want to produce a 3D plot. Okay, so you can see an empty 3D plot is there for your reference. Okay, that's a standards code you need to follow. Okay, if you want to introduce a 3D axis, so there are three these here. Okay, one, two, three, fine. And I have given a plot example also. So suppose using a 3D axis you want to plot. So I have import the necessary modules. Then I have changed certain parameters of my plot. Like I want the legend font size to be 10, so I have used rc params argument. Now this is a different type of function. Rc params can be used when you want to define your own parameters, means there are certain arguments which are defined within the function. Okay, standard arguments, and there are certain arguments which you can customize according to your requirements. That can be done with the help of rc params. So I want my legends font size to be 10, then plt dot figure. Okay, so now I want to produce a 3D projection. So this is a standard code you need to introduce. Fig.gca, you want a 3D projection. These are my x and y values, and then I want to have a line plot. Okay, so if I do this and I try this command here and I run this, so now my line plot is within the 3D axis. But as I said that the beauty of 3D plot can see, or you can have an ideal use only if you are having a large number of variables. Otherwise, it is of not much use. But you should know you should know how to introduce 3D plots into the with the help of Matplotlib, and how to basically put data into it. All right, it's a very important knowledge you need to have if you're learning data visualization. Okay, so that's all on the Matplotlib library. Now from the next sessions we would be continuing with the C1 library, which is an exclusive addition to the Matplotlib, and you will find very interesting stuff in the future sessions, a little advanced, a little more deep, and will take you more into the regime of what's say an excellent data visualization. Till that time, keep plotting. Happy plotting.